full strategy. So what I did was I made a handout. Okay, we're going to go through that again, and I made a handout that I think will, I hope will facilitate that. So I'm going to start sending the handout around while I get the outline up on the board. Let's start that. Thank you. Okay, so this is kind of a long outline. First thing we're going to do today is talk more about strategies, actions, and equilibrium, how those terms relate to each other. We'll do a little more strategy counting so that hopefully you'll get more comfortable with that. Then we're going to talk a little bit about, we're going to go to a sort of a broader view and talk about game theory in general. The scope of game theory, how broad is the set of situations that we can analyze with game theory, what are some of the limits. We might start talking about variable payoffs, but the stuff down here that I can see some of you guys craning your necks to try to copy down, very doubtful that we'll get this far. This is more of a what's ahead for next week on the syllabus. Okay. Also a reminder that your problem set is due on Tuesday. Okay, the due date on this homework is right on the homework assignment, right on the top, just like it'll be on all of them. You don't need to email me or your TA about that. Just check out the homework, and it's there. In lecture, okay, so bring them with you to class to hand them in. All right. Final preliminary remark, I'll put it up here. I got a request to recommend some extra problems beyond the homework. I'm doing this periodically. For where we're at right now, my recommended problems would be Dixit and Skeeth, number 1 through 5 in chapter 3. I will at some point be able to post answers on the website for those, probably not till late next week. Okay, but even though it's only 5 problems, the problems have a lot of parts, so that will give you a set of things to work on to help. All right. So what I'm going to do now is I'm going to turn to the handout that I just sent around on strategies in the fundraising game. What became clear to me at the very end of class on Tuesday was that there were sort of 2 things going on that people were confused about. One is the issue of what a strategy is. Okay? Someone want to tell me what a strategy is? Yeah, me. A combination of players that a combination of players. Let me say what Neve said a minute ago. A combination of actions that a player will take. How many? Someone else. How many actions in a strategy? Yeah.
An action for each node.
An action for each decision node. Very good. What's your name?
Kenny.
Kenny. Okay. So a strategy, remember this from Tuesday, is a bigger thing than an action. Actions are our building block. The components of a choice are what of a set of actions I can take. But if we're in a game tree and I'm a player that controls more than one decision node, my strategy has to give me an action for every node. Okay, so if it's a very big tree, if I have 6 decision nodes, each one of my strategies has to have 6 actions in it. It has to tell me what to do at every point that I could possibly find myself in. Okay? So strategies are bigger than actions, and an equilibrium is bigger than a strategy. A strategy is a set of actions, one for each node. An equilibrium is a set of strategies, one for each player. Okay? So right now, I'm going to still keep the focus on strategies versus actions. I will go over the business about equilibrium at the end. So that's the conceptual issue. And just from hearing the responses and generally looking at the faces, I think you guys are comfortable with the conceptual issue. There's this other issue that is not hard to think about, but is an annoyance, and that is how to write down a strategy. Okay, that's, I think, where things got a little confusing at the end, and that's why I thought the handout would be a good choice. The handout refers to our fundraising game, which I think you guys probably have committed to memory at this point. And what the handout does is it writes the strategies for the challenger 3 different ways. And basically, we'll be using all 3 of those ways. As I indicated on Tuesday, and it's still true, it was true on Tuesday, it's true now, this middle way of doing it, what I call abbreviation style 1, is the way that I would consider the default. Okay? To me, it's the way that we do it most often. Okay? It's, in my mind, a nice combination of enough words that you know what the strategy actually is, but it doesn't take forever to write out. What I think I may have overstated on Tuesday is I think it's an overstatement to say that this is the only way you need to write strategies. The fact is, the reason why there are different levels of abbreviation is that sometimes you want a very terse abbreviation. When you have a game with a lot of nodes in it, it does become very cumbersome even to write out simply RF if RF, RF if N. It becomes easier when you're managing a lot of nodes just to list the strategies in order. Okay, that's abbreviation style number 2. This is the most abbreviated way to do it. As I said before, that's a way where if you're not careful, you can lose touch with what those strategies actually mean. Okay, another way to think about abbreviation style 2 and about abbreviations in general is that they are a way of saving space on a page. They're a way of saving writing time, but they're not necessarily a way of saving thinking time. Okay? The shorter the abbreviation, the more effort you have to put in to decoding it. Okay? So the very abbreviated style, while I'm talking, I'm going to put our familiar game tree back up on the board just to illustrate. The very abbreviated style, where you simply write the strategies, write the actions in the order that the nodes occur, is pretty terse, and you have to take a minute, you have to take a deep breath when you look at abbreviation style number 2. The first strategy here is telling me that the challenger should raise funds at this node and raise funds at that node. The second strategy is telling me that the challenger should raise funds at the leftmost node, not raise funds at the next one. Okay? It's telling me exactly the same thing. Strategy 2 double prime here is exactly the same thing as 2 prime and 2. Okay? So the idea here is to give you this list of 4 strategies for the challenger, different levels of abbreviation, to emphasize there are different ways of representing the same thing. Okay? There will be times, in fact, there may be a time in about 2 minutes when I go to the next game I want to analyze, when the very abbreviated style is what we want to do. Okay? When we really do want to be as short as possible. One context came up at the end of class Tuesday when I was asking you questions, hoping that some of you would call out responses, and you guys in general are pretty good about doing that, but it's a lot easier to call out LLL as a strategy than LFL, LFR, LFM. Even just doing it like that, I messed up the order in a way that made it a little bit unintuitive. Okay? So get comfortable with using all 3 levels of abbreviation, but when in doubt, my recourse is to use abbreviation style number 1, and I would recommend that to you. Okay? Another thing I want to underscore that I meant to put on the handout, I'm actually not seeing it here, so let me underscore it even more loudly, is that the book has a good treatment of this exact subject on the business of writing strategies and counting strategies. See Dixit and Skeeth, pages 58 to 59. Okay? Same thing that I just went over in the context of a slightly different game. I think it always helps to see the same idea in more than one context. Okay. So, still not done with this. I want to go back to that boring game that I put up on the board at the end of class Tuesday, the fascinating choice of left, middle, and right. So let's put that game back up and talk about those strategies for a moment. Okay. So in that game, we had player 1 with now a 3-way choice. Player 1 can choose left, middle, and right. And then player 2 just chooses left and right. This is the first version of the game that I had on the board, not the little variation that I went to. Okay. All right. So again, revising what we went over on Tuesday, the first mover, as in the fundraising game, the first mover's strategies are easy to identify and easy to count. The first mover has only one decision node, so the first mover has 3 strategies. Each strategy has only one action. Okay? The second mover is a little more complicated. The second mover's strategies have 3 components. Okay? So we know that the second mover strategy has to have 3 actions in it. What to do at this node, what to do at that node, what to do at the rightmost node. Okay, so 3 components. The total number of strategies is these two combined with each of these two. That's 2 times 2. Okay, so 4 possible combinations here multiplied by each of these two. The total number of strategies here is 2 times 2 times 2 is 8. Okay, so 8 total strategies for player 2. And on Tuesday, we did not list them all, so what I want to do now is just sort of systematically list all of them. And this is a context that, as I just alluded to a moment ago, where I'm going to use the most abbreviated style. Okay? I'm going to list all of her strategies. Okay? And this is just how I'm going to do it. When you're asked to list all strategies, it's good to be systematic. The way in which you're systematic, there's more than one way to be systematic. I'll show you my way. Okay, one thing player 2 could do is do left here, and left here. Okay, so that's one. Left, left, left. Another thing player 2 could do is left here, and right there. Okay, left, left, right. Another thing player 2 could do is do left here, right there. Okay. Yet another thing would be right, right, right. Another one, right, right, left. Actually, let me start a new column here just to keep it. I know I'm going to have 8, so I'm halfway there. Let's put right, right, left up here, but let's put semicolons in between so that we keep them separate. Right, right, left. Okay. Right, left, right. Right, left, left. And what have I left out? You tell me. Left, right, left. Very good. Okay. There they all are. There are 8. These are all the strategies. If we had wanted just to even use abbreviation style number 1, it would have taken a lot more time and a lot more board space. But again, let's translate this into first abbreviation style number 1. And let's pick a more mixed one. This strategy here, translating right, left, right, means the same thing as right if left, left if middle, and right if right. This would be abbreviation style 1. Abbreviation style 1 is a little closer to ordinary language because it tells us what player 2 should do and specifically tells us what action of player 1 corresponds to this. Okay, so it's identifying the nodes of player 2 in terms of the action of player 1 that led to the node. If we really wanted to say it in ordinary language, I'll say it, but I'm not going to write it. This strategy would be, okay, starting now I'm saying the strategy. Choose right if player 1 chooses left. Choose left if player 1 chooses middle. Choose right if player 1 chooses right. That's the end of the strategy. That whole mouthful is the strategy. I'm not done saying the strategy until I've said all of those parts of it. Okay. All right. On Tuesday, yes?
So that one complete strategy is made up of 3 actions, right?
That's exactly right. That's exactly right. One complete strategy, 3 actions, 3 different ways of saying one complete strategy. Okay? That's why there's kind of a lot to get all together here, both thinking about what the strategy is and thinking about how to talk about it. On Tuesday, I didn't put payoffs in the game, but I think this would be a good game to also think about finding the equilibrium of and to underscore what an equilibrium is, since it's an even bigger thing than a strategy. So I'm now going to put payoffs in. Okay. So it hasn't actually been a full game tree until the payoffs are in there. So here are some payoffs. 2, 2, 0, 5, 5, 0, 6, 2, 2, and 1, 3. Okay, so this game has, what, 6 terminal nodes, 6 different paths that the players can take. And for each terminal node, I've written down the payoff for player 1 first and for player 2 second. Now I have the whole game. Now I have something that I can solve. And as is going to be the case with every sequential game that we do in Poli-Sci 30 and every sequential game that you do in the rest of your life, we start at the bottom and work our way up. We solve the game backwards. Okay? We solve it by thinking about what if we get to this node, what will happen? What if we get to that node? What if we get to that node? We use what we find by analyzing the second nodes to figure out what will happen at the first one. Okay, so we're solving it from the last thing that will happen up to the first thing. We're doing that because we think the players are strategic and the players are thinking ahead. If player 1 is thinking ahead, she's not thinking, do I like left, middle, or right better? She's thinking, do I like what player 2 is going to do if I choose left, if I choose middle, if I choose right? Player 1 is trying to anticipate. Player 2, if we want to understand how she anticipates, we have to anticipate also. So if we get to this node, what's player 2 going to do? Left. Player 2 is looking at player 2's payoff. 2 is greater than 0. Player 2 is going to choose left. Okay. Again, to emphasize, when I solve games, my way of doing it is to highlight the branch that is going to be taken. Dixit and Skeeth's way is to cross out the branch that is not going to be taken. You can do it either way as long as you're consistent. If we get to this node, what's player 2 going to choose? Right. Player 2 says, wow, 6. 6 is good. I'd like to have 6. 6 is better than 5. This node, what's 2 going to do? Right. Okay. So now that I've figured out what 2 is going to do in this lower part of the tree, I don't need to pay any attention to it anymore. I can just replace this whole set of nodes with the strategic equivalents. The strategic equivalent is the payoffs associated with the optimal choice. Okay, so the strategic equivalent of this node is 2, 2. The strategic equivalent of the middle node is 0, 6. And the strategic equivalent here is 1, 3. Okay, so I'm copying the payoff that corresponds to the action that we think player 2 is going to take here. Player 1, and now we're ready to figure out what player 1 is going to choose at her node. Player 1 is going to be thinking in terms of these strategic equivalents. So what is player 1's best choice? Left, right? Player 1 can get a payoff of 2, a payoff of 0, a payoff of 1. Okay? So now we've solved the game, and we're at the point where we can write down the equilibrium. That's maybe the final step here. By solving the game, we've identified what we expect to happen. Okay, we think that 1 is going to play her equilibrium strategy. 2 is going to play 2's equilibrium strategy, and we're going to get to this outcome. Yes?
Player 1, do they pick that strategy just because they're like the number of their outcome? Or like if their outcome, if at the end of it, like their outcome was high on that side, but it also gave player 2 a high outcome and not an equal one, would they still pick that?
Very good question. What's your name? Kenyatta's question is, does player 1 always just look at player 1's payoff? And the answer is yes. Okay? Kenyatta went on to wonder, wouldn't player 1 maybe sometimes look at player 2's payoff? Like especially in a case if player 1 had a tie, do we think that player 1 might look at player 2's choice? The answer is no. Now that seems a little bit excessively mean on the part of the players, right? I mean, we hope real human beings are a little bit better than that. If we think the players care about each other's preferences, then what we would do is we would put something in player 1's preference that would reflect player 2's high preference. Okay? And we can do that either when player 1 gets a higher payoff by helping player 2, or when player 1 is even meaner than these guys and gets a high payoff from hurting player 2, right? That's a possibility too. So if we think that the players care about each other's payoff, what we do is we add something into the other regarding player's payoff to reflect that. Okay? So what we want to be able to do when we're solving the game is to just have one number to look at. Okay? So these numbers, the players' payoffs, have to incorporate everything that goes into the player's preferences. So if the player likes the other player, the player who does like the other player's payoff should be higher to reflect it. If the other player is spiteful and wants to hurt the other player, that should be in the player's payoffs as well. Okay, so we could do that in the fundraising game. Okay. So if we were asked to predict what's going to happen in the game, what we would predict about what we would observe is that player 1 would choose 1, player 1 would choose left, player 2 would choose left. We'd end up here. This, actually I think I'm going to switch colors. I've got a system here. What's in black is setting up the game. What's in red is solving the game, and what is now going to be in blue is going to be kind of analyzing the solution, interpreting the solution, talking about the solution. Okay? So one thing we can say about the game, if we're analyzing it, is that this would be our predicted payoffs, and the predicted outcome is left, those payoffs. Another way to say that is that the equilibrium path is left. Okay. You guys aren't going to like this, but it's true. Here I'm saying left, and it's not a strategy. Okay, it's not a strategy because on the equilibrium path, I'm talking about player 1 choosing left and player 2 choosing left. Okay, so sorry about that. It's the way it is. Those actions, they're fundamental. We could put them together lots of different ways. When we string together the actions of one player, one for each of their decision nodes, we call that a strategy. But when we string together the actions for different players, that's the way we would specify the equilibrium path. Equilibrium path is not the same thing as equilibrium. Okay, it's a narrower thing. Okay, so the equilibrium in this game, what am I looking for when I'm looking for an equilibrium? Yeah, Nita. For each player. That's exactly right. Okay, so I'm going to just repeat what Neve said. The equilibrium, the first thing is it's a set of strategies. Remember, equilibria are our biggest thing. Strategies are composed of actions, and equilibria are composed of strategies. Well, how big is the set of strategies? The answer is 1 for each player. Can they be any old strategies? No. The strategies must be, I'm going to write best responses. I'll say some more about that. Best responses to each other. What that means, if you go back to your notes from Tuesday, I talked about this for some time on Tuesday, is that given one player's strategy, the other player has to be doing the best she can, and the reverse, okay? So given player one's strategy, player two's has to be the best response. And the best response, again, let me emphasize Kenyatta's point. Player two's best response means the response that gives player two the highest payoff for herself, okay? So looking at the best response from player two's point of view, you just look at player two's payoff. It also has to be true the other way around. Given player two's strategy, player one's equilibrium strategy has to be a best response. Player one can't get a better payoff for herself by doing anything different than her equilibrium strategy. That's what it means for the strategies to be in equilibrium. Given what you're doing, I can't do better by making a different choice. Given what I'm doing, you can't do better by making a different choice. The strategies are reinforcing each other. Yes? That's exactly right. The equilibrium path is not a strategy. And actually, even an equilibrium is not a strategy. So, an equilibrium is a set of strategies. An equilibrium path is a part of an equilibrium. Okay, so it's sorry the taxonomy is getting so detailed here, but good that you guys are picking up on it. Actually, let me maybe write the equilibrium path over here just below equilibrium. Okay, so the equilibrium is our biggest thing. We build it up from strategies. Then we can take apart the equilibrium, and this is, I think, the point. Let's see if I can remember your name. Are you Kiara?
Wow.
Okay, good. I'm not sure I can do that with everybody, but I'm trying. What Kiara's point is that you could take apart the equilibrium then in different ways. The equilibrium path is the part of each player's strategy that we expect to see. Okay? So in this equilibrium over here, let's go ahead and write out the full equilibrium and then find the equilibrium path part of it. The full equilibrium is what we find when we solve the game backwards. Okay, we find the best strategy for player two because we're finding the best action for player two at every point that could occur in the game, and we're finding the best strategy for player one. Same story. So player one's equilibrium strategy is to choose left. Player two's equilibrium strategy is left if left, right if middle, and right if right. I have one more color left, so let's get one further layer of notes here. This is player one's equilibrium strategy. Player one has three possible strategies, but only one is part of an equilibrium. This whole thing is player two's equilibrium strategy. Okay, so of all 8 strategies that player 2 has, only one is part of an equilibrium, okay, because only one can be in the self-reinforcing relationship with one of player 1's strategies, and the one that is the part of the equilibrium is this one. Okay, right? Just abbreviation style 2, abbreviation style 1 there. The equilibrium strategy of player 2 is choose left if player 1 chose left. Choose right if player 1 chose middle. Choose right if player 1 chose right. L if L, R if M, R if R. LRR. Okay, so from the most long-winded to the tersest there. This is the strategy. It's the biggest thing. It's the strategy of the second mover in this case is composed of actions, one for each node. It's also true for player one, but she only has one node. And the equilibrium is composed of strategies, one for each player. So now we've gotten as big and complicated as we possibly can. The other thing that we can do is we can identify the equilibrium path. Okay, so now I'm switching back to black here. The equilibrium path is what we expect to actually happen. We don't actually expect to see player 2 choosing right, okay, because we're not going to get to this node. We're not going to get to that node. Player 1's not going to go there. Player 1's not going to give player 2 the chance to choose 0, 6. Player 1's not going to give 2 the chance to choose this 1, 3 either. The equilibrium path is, you could see it in the tree by actually finding the connected path that begins at the top node and goes all the way down to the bottom. Okay, there's only one path here, right? It's this one and this one. It's this part of the equilibrium. Okay. So when we build up an equilibrium, we do it one strategy at a time. Player 1 strategy, player 2 strategy. Then when we think about it, we divide it up a different way. We divide it up into what we think will happen on the equilibrium path, and then what's left is what is off the equilibrium path. Okay, this is still part of the equilibrium. This is the part of the equilibrium that lets us know why player 1 chooses left. You might be looking at these payoffs and noticing that the equilibrium payoff, 2, 2, doesn't necessarily seem to be the best choice for player 1. If player 1 chose middle, there is this payoff of 5 for her right here. So you're thinking, why doesn't player 1 choose middle? You tell me. Why doesn't, yes? Because it gives player 2 the opportunity to choose right. What's your name back there? Tiffany. Tiffany got it exactly right. The reason why player 1 chooses left, which might seem like sort of a mediocre choice here, why settle for 2 for both of us when we could both have 5? Tiffany gives us the answer. Because if I'm player 1 and I choose left, look what player 2 is going to do. Player 2 is going to double cross me. Yes, we could both get 5, but player 2, I know what she's like. She's going to choose R. We're going to go here, and I'm going to get 0. I'd rather safely have my 2. So the idea here is that the off the equilibrium path, part of the equilibrium, we never think it's going to happen. We don't think we're going to observe this choice or this one, but it's our understanding of why things go the way they do. Okay? Why strategic considerations lead us to outcomes that don't seem so good. Okay. All right. I think I want to do one more example like this. Was there a question? There? Okay. No, let's do one more example. It's going to be another of these exciting right, left, right games. This is going to make you guys not so sick of the incumbent and challenger as you might have been on Tuesday and really happy to get back to that old example. Maybe not. But while I'm cleaning up the board here, just kind of in your own notes, take a look at that game and in terms of the number of actions, the number of strategies, what was the equilibrium? Yes? Okay, so mostly the question is, how do we pick a baseline? As I've said a couple times, the numbers are kind of arbitrary. What's your name?
Kira.
Kira is saying, well, if you say that the numbers are arbitrary in the homework, how do we start? For the homework, I've given you lots of numbers in the homework, so you don't have to make up as many numbers as I do. But as you're saying, you do have to start with a baseline. I recommend a baseline of 0. There's no reason not to use a baseline of 0. Okay? So when it talks about adding units of utility, subtracting units of utility, if you wanted to start at 75, you wouldn't get a wrong answer, but why not give yourself something easy? Okay? Okay, was there another? Yeah?
I just wanted to clarify, is the equilibrium rollback strategy the same thing as the equilibrium?
Yes. What's your name? Amy's question is the equilibrium rollback strategy the same as the equilibrium? I'm going to really split hairs here. The rollback equilibrium is the same as the equilibrium. So let's do a board right here. Rollback equilibrium, that's what the book consistently refers to it as, for right now is the same thing as what we're calling equilibrium. Okay? It's also true that the rollback equilibrium strategy is the same as the equilibrium strategy. The hair that I'm splitting here is that when we say equilibrium strategy, we mean a strategy that's part of the whole equilibrium. If we just say equilibrium or rollback equilibrium, we're meaning a set of strategies. Okay? So when we're talking about one strategy and saying it's an equilibrium strategy, the point we're making is that not every strategy can be part of an equilibrium. A minute ago, I had all those different strategies for player 2 in this game, and there was only one of them that was part of an equilibrium. Okay? What you'll find later in the course is that what rollback means is it's a process for finding an equilibrium. We'll find the same kind of equilibrium when we get to simultaneous games, but because the play there is simultaneous, we're going to represent them in a way different than a tree, and the process will be different than rollback. Okay? But for right now, same thing. Okay, other questions? Other questions? All right. So all I'm doing in this example is I'm kind of not exactly switching the roles of player 1 and player 2. I guess I am. I'm switching the actions available to them at all of their nodes. Now I'm saying that player 1 just gets to choose left and right. And once player 1 chooses, then player 2 is the one that gets to choose middle or not. Left, middle, right. Left, middle, right. Okay. So small change, but let's see now how all of those issues work out. How many strategies does player 1 have? 2. How many strategies does player 2 have? 9. Very good. Oh, you guys got that right away. Okay? It's 3 strategies here multiplied by 3 strategies here. 9 different strategies. Okay? Let's put some payoffs in there then. And I'll just put the same payoffs in the same order. So literally I'm going to have the same set of terminal nodes, just as we did before. We have 6 different possible paths that the tree could take, but we will get a different equilibrium. Of course we'll get a different equilibrium because now player 2's strategies are going to be different. How many actions will player 2 have in each of her strategies? 3. Okay, let's think about that. Let's think about how many strategies they'll have. Anybody want to amend? How many actions? There'll be 2, right? Now player 2 just has 2 decision nodes. So if we're going to, it actually doesn't take that long to list player 2's full set of strategies here. Okay? I can do left, left. I can do left, middle. I can do left, right. I can do middle left, middle middle, middle right. I can do right left. I can do right middle. I can do right right there, all 9 of them. And you see they do have 2 components. Okay, so this is the full set of strategies. Now I'm going to put those same basic payoffs in a different tree structure here. Okay, 2, 2, 2, 0, 5, 5, 0, 6, 2, 2, and 1, 3. Okay. This is such a nice pen, I don't want to lose the lid to it before it dries out. So, solving the game backwards, what's player 2 going to do if we get to this node? And let me emphasize, that's a 2, 0 there, that kind of strange looking thing here. That's a 0. Right. Yeah, right. 5. That's a great payoff. I'm player 2. I can't wait to get 5. What's player 2 going to do at this node? Left. 6 is even better. Oh, love this game when I'm player 2. Strategic equivalence then of this node, 5, 5, this node, 0, 6. I'm player 1. What am I going to do? Left. If you were player 1, would you rather play this game or the other one? You'd rather play this one, and it's kind of interesting, isn't it? In this game, player 1 has fewer choices than she did in the other one, right? In the other one, player 1 had a choice of left, middle, and right, and player 2 had fewer choices. But in this strategic situation, player 1 actually does better in a case where she has fewer options, okay? Because it allows her to get to a choice that's better for her and better for player 2. That's something that's going to happen in a lot of our games. It's an interesting and I think kind of non-obvious aspect of strategic situations. If you just looked at the 2 games side by side without solving them, I think many people, myself included, at least before I learned game theory, would be tempted to say, well, player 1 always does better when she has more choices, right? That's how can you go wrong with more choices? Well, you can. You can go wrong with more choices if those choices can put other players in a situation that could hurt both of you, or that could hurt you. So we're going to be looking at some substantive examples that have that very feature. All right. Just finishing up the details here to make sure that we're remembering what is the equilibrium and what is the equilibrium path. Okay, I'm going to use blue. It's a better pen than my green one. When I'm looking for an equilibrium, I'm looking for a full strategy for each player. Okay, so my full equilibrium, I'm going to write it out in words this time, a little less abbreviated than before. Player 1 plays L. Player 2 plays R if L, L if R. Okay, so again, equilibrium has a strategy for each player. Each strategy has an action for each node. Okay, 2 players, 2 strategies, 1 node, 1 action in player 1's strategy, 2 nodes, 2 actions in player 2's strategy. Out of player 2's 9 possible strategies, 1 is part of an equilibrium. Out of player 1's 2 possible strategies, 1 is an equilibrium. The equilibrium path, again, is the part of each player's strategy that we actually expect to see. Okay? So the equilibrium path we see in the tree by looking at the path of best actions that begins at the terminal node, begins at the first decision node and goes all the way down to a terminal node. Okay, it's the set of connected actions here. This is the equilibrium path. The equilibrium path is also a combination of actions, but now it's an action for each player at each of their nodes. Okay? In an equilibrium path, you can actually have an action, a player that has more than one actions if they have more than one round of nodes. Okay? So if this was a more complicated game where player 1 made a choice, player 2 made a choice, and then player 1 had another set of decision nodes, the equilibrium path would actually have 2 actions for player 1. This is the equilibrium path in the tree. If we just look for it in the strategy, it's this. Okay? The part of each player's strategy that we actually expect to observe. What's in the equilibrium but not in the equilibrium path is the off the equilibrium path component. Okay? Sometimes we think of these off the equilibrium path components as threats that never get exercised, bluffs that never get called, punishments that never need to be invoked. And game theory really, really draws our attention to these counterfactuals. If we want to understand why player 1 chooses left, it's not so puzzling with these payoffs, but if we want to understand it, we have to think about what would happen if she did something different. Can't say that often enough. Okay. Anybody want to say anything else or ask anything else about left, middle, right? Okay. Yes?
So, if we get a problem like this on the test, can we, like, is that a correct way to, like, do we have to do more writing, explanation?
That is a very good question. What's your name? Caitlin's question is, if there's a problem like this on the test, can we just write down what's on the board? Should we do more writing? You should do more writing. Okay? On tests and on homework, err on the side of more writing. And the way to think about this is, I don't know if anybody's watching those webcasts of the lecture, but do the lecture with the sound off and see how much it makes sense. So what you would want to write is not quite all the words that I'm speaking here, but enough of the verbiage that is going along with this that somebody can follow the whole argument. Okay? I'm so glad you asked that, because I think sometimes people come into game theory and think, oh yeah, this is a class about numbers and variables. She really just wants me to do symbols. No. What I really want you to do is I want you to be able to use symbols and words together, to be able to go back and forth between the numbers and the words, the abstract representation and what it really means. So your homeworks and your exam should have both of those things. Okay? It is a good idea on your homework and on your exams to use color the way I do. When you do it, if you want to do like a little code saying red denotes the solution of the game, green denotes the equilibrium path, that kind of thing can be very helpful. Okay, so what you want for your homework answers and for your exam answers is to have a coherent explanation of the question. Another way to remember that format is this idea of translating a real-world problem into game theory, doing the game theory work now, which now we know how to do that, find the equilibrium through rollback, and then translating it back to words. Okay, so it's both words and symbols are important. Yes?
So just to clarify, is a path then like an intermediate between an action and a strategy?
So what's your name?
Lillian?
Lillian's question is a path an intermediate between equilibrium and a strategy? It's not exactly. The way I would think of it is, I'm going to see if I can on the fly draw a helpful picture. Always risky, but we'll try. Okay, so we have actions, and I'm going to do them like A1, A2, A3, A4, A5, A6. These are actions. Actions come together to form strategies. Okay, so we'll call this S1, S2. And then strategies come together to form an equilibrium. Okay, now there's something different going on in the way actions form strategies and the way strategies form equilibrium. Okay, we add up actions to find a strategy. All we need to do is make sure that the actions belong to the same player and that they correspond to the choices at her different nodes. For equilibrium, it's a little more restrictive, right? It's not just a strategy for each player. They have to be strategies that are best responses. But again, there is this idea of successively building up. Lillian's question is, how do we fit equilibrium path in here? It would be something like this. Okay? So in the context of a specific game, the actions always come right from the story. The actions really are the choices that the players can make in the real world. The strategies come from the game tree. Okay, once we've got the game tree, then we know how complicated the strategies are for different players. Sometimes they're very simple, as with the first movers here. They get more complicated typically with the second movers. In finding the equilibrium, we have to solve the whole game. We have to find two strategies that are best responses to each other. Okay, two strategies where, given what you're doing, I don't regret what I'm doing, and given what I'm doing, you don't regret what you're doing. Okay, where neither one of us has a reason to change. Then, once we're done with all that, we've got the biggest possible thing. We've got this combination of strategies, one for each player. Each strategy is an action for each node. The equilibrium path is kind of cutting up that equilibrium in a different way. One thing about the equilibrium path that I think is relevant for Lillian's question is it is the part of each player's equilibrium strategy that we expect to see played. Okay? So an equilibrium path is composed of strategy parts. Okay? And it would never be the parts of a strategy that add up to a whole one. It's always parts of different players' strategies. Okay? So it has to, the equilibrium path, a way to think about that is every action we expect to see played. Okay. Okay. All right. I'm going to erase this while you guys are thinking if you want to ask any other stuff about that. And if not, if you're already sure that you don't want to ask anything about that, start thinking about this. Go back to the fundraising game. And while I'm erasing, let me pose this question to you. How could that game be better? You guys think about this, and when I'm done erasing, give me some ideas. How could that game be more interesting, more realistic? Just how could you improve it? So. Elaine's question, I think if I'm understanding your question correctly, is the first player's strategy is always just the same as her actions. That's right. That's exactly right. In these sequential games, the first player, well, let me add one qualification to that. As long as the first player doesn't have another move, that's true. Okay? If it was a game, let's kind of turn our attention back to the fundraising game. if it was a game where I don't know, something important's going on out there. If it was a game where the incumbent could raise funds or not, the challenger raise funds or not, raise funds or not. If this was a game where if both players raised funds, say, then the race would attract media attention, and say only in this case would there be a choice of the incumbent to go negative or go positive. Okay, that's kind of an off the top of my head example. But now the incumbent's strategy, even though she's the first mover, what to do here and what to do there. Okay, and depending on the payoffs, it's possible that we would never get to this node. Okay, it's possible that her part of the equilibrium path could have one strategy, one action, something I don't want you guys to do. It's possible that the first mover's equilibrium path could have just one action because this node might not be on the equilibrium path. We might go down here, but it's also possible we could go down here, in which case the incumbent's equilibrium path would also have two components to it. Okay. So a lot of different possibilities there. All right, but there by itself, for example, is something we could do to change the game. I'm just adding the payoffs back in here. While I'm doing this, make sure I'm doing this part right. We're getting into, the Bermuda Triangle of class where I start putting numbers in the wrong place here. I think those payoffs are right. So there it is in all its glory. What are some ways to do it differently? Yes? Oh, yes. Yes, what's your name? Paul says, raising funds isn't always a sure thing. That I'm assuming here that the players not only can control fundraising, okay, but also they know it with certainty, okay? And I think that was sort of implicit there. And I'm going to highlight business about the outcome, not necessarily a sure thing. Okay? I'm the incumbent. I raise a lot of funds, and the challenger does too. Maybe in the course of the campaign, something bad comes out about me, or maybe my party is doing badly in the electorate in general, but I might not necessarily get this. Okay? So one concern about how much this game tells us about real congressional elections, well, there's two concerns here, that maybe there are other players here, okay? Other people, donors, for example, might control how successful fundraising is. Voters might also control it in the sense of how much people respond to the kind of activities that funds are used for. So other players and outcomes not being certain. Other thoughts. Okay, what I would like to do is kind of get a list of concerns about the game, a list of ways to improve it, and what I want to then do with the concerns is to think about which ones we could address just within game theory, okay, by changing the assumptions of this game and setting up a different game. Okay, and Paul's concerns are both ones that we could address within game theory versus ones that would really take us outside of game theory. Okay, and so there'll be, I think, some things in both categories. What are some other thoughts? Yes?
When dealing with something not maybe like an incumbent and a challenger, but like two equal players, how do we know who's on top and who's
Okay, what's your name?
Brandon.
Brandon's question is, Is it even clear? Okay, I was even in this example, I made some sort of pitch for why it was clear, but you might think that in some cases, in open seats, say, it would not be clear. Okay? Other thoughts? Yeah. No? Yes?
What if the incumbent doesn't fully raise, like he raises funds but he doesn't raise enough funds, so you still get the same amount of utility, or does he take it back?
So part of your question here is fundraising isn't really just a yes-no thing. It's raise a little, raise a lot, raise a humongous amount. The way to think about it in general is that fundraising has many choices. If you wanted to go to an extreme that wouldn't be that unrealistic, is fundraising is a dollar amount. Okay? You can specify how much fundraising to do to the penny, right? There's a whole lot of actions there. That's sounding a little hard to manage, but actually that is something we could manage. Okay? Other thoughts? Yeah.
Well, it seems like we're assuming that, I think it's, I guess, presuming the challenger will raise funds not depending solely on the fact of whether or not the incumbent raised funds not. There could be a lot of other factors playing into that.
In the environment. What's your name?
Steph.
Steph's point is other factors influence the second mover. Okay? What she's saying is there's all sorts of reasons why the challenger might decide to raise funds or not, and the incumbent strategy is only one component of that. Okay, that's a very good point, and I want to add to it that the incumbent might not be able to anticipate all those other factors. Okay? So one thing you might think of in this particular context is, okay, so I'm a challenger, I'm running against an incumbent, and I'm not dumb. I know that my chances are not good. I understand politics. I went to UCLA and I took 141B and 140A and I took PS 32, and I know that it's not good to be a challenger. I'm not going to win this election, but that's not all I care about. Okay, I'm taking a real long view. I've learned to look forward from Professor Bawn, who tells me to think about all the consequences of my action, and I'm even thinking about the next election. Okay, I'm thinking if I work really hard right now, people are going to notice that. Maybe a lot of people won't, but maybe some donors will notice it. Maybe people in my party will notice that even in a case where I wasn't very likely to win, I was able to raise a lot of money. I did better than expected. Okay, maybe I lost, but I got 35% of the vote in a district that had favored the other party. Okay, that would be something that I would care about. Now, if that was known for sure, we could put that into the game. What would make it even harder, but we could still put into the game, would be if the incumbent's not sure whether I'm that type of person or not. Okay, whether I'm somebody who's going to raise funds no matter what because I'm thinking about my full career, or maybe I'm somebody who, no, if I'm not going to win this election, that's enough for me. Okay? Both of those things would make the game more realistic, and we could incorporate both of those into a game. What I want to do a little bit of talking about how we might incorporate some of these different things into different games, how we might address some of these challenges, some of these elaborations within game theory. Many of them have this issue of the players not being certain about things running through them. The outcome might not be a sure thing. It might not be clear which one of us is going to make the first move. The very general version of Steph's point is the players might not necessarily know each other's payoffs. In order to solve the game backwards, that was kind of the key thing. Okay? The first player had to know the second player well enough to predict her actions. Okay? Otherwise, the business of finding the strategic equivalent wouldn't be possible. If the incumbent up here is saying, well, I don't like to raise funds and I have no idea how my challenger is going to respond to it, then it's harder for that incumbent to be strategic. Okay? This issue is one that I would say is right on the border of an issue that we can solve within game theory. Probably by the end of next week, certainly by week 4, we'll be talking about having uncertainty in a game. What to do when the players aren't sure about what their opponent wants, aren't sure about what their opponents can do, aren't sure about the consequences of their own action. That's a ubiquitous feature of the world. And we are going to find a way to put that into the game. What I will say is the more uncertainty there is, the harder it gets to say something definitive about how they're going to make strategic choices. I guess that shouldn't be surprising. Okay? So with that, you guys are in good shape to do your homework problem. Go ahead and have fun with that, and we'll see you on Tuesday.